Alright, welcome to this video. In this video, we're going to describe something near and dear to my heart. I hope to make this pretty quick because it's a pretty simple concept. However, I frequently see students making mistakes with this, and I want to clear up any confusion for you, okay? The topic of this video is making measurements and some simple properties of measurements. We're going to define some key terms. Importance, I rank this as 2 out of 4 for the exam. You might not see a problem exactly like this on your standardized exam. However, knowing how to do this is absolutely crucial for professional lab work. And there's really no excuse not to employ these very, very simple rules when you're working in the lab. It's a pet peeve of mine, as I mentioned, as it is also your TAs. And we need to make sure everyone's on the same page, okay? So what this tutorial is going to involve is making measurements, how to read data essentially from measurement devices. And there's a very, very simple rule to aid in doing this. It's to measure all the digits possible with your measuring device to its precision, and then estimate 1 additional digit. Okay, you're allowed to estimate 1 additional digit beyond what you can measure. That digit that you estimate, we're going to call that the least significant digit. Let's just jump right in real quick here, try ourselves an example problem. So what I've done here is I've printed out a little dial, and I'm going to work through the process of actually making a measurement based upon the placement of this dial. Sometimes you have to do this in the lab. We're going to read this top scale, which is a transmittance scale, like on a Spectronic 20 spectrophotometer. It's a little dial, and that dial moves based on what the transmittance is. So let's just say that this is your reading, and you want to make a reading. I want to demonstrate for you this ability to estimate that last digit and read as much as we can. Okay, so as I look at this, the dial is clearly between 70 and 80. And if I look at the little partitions between 70 and 80, it looks like there's 10, right? 71, 2, 3, 4, 5, and so on, okay? So as I'm looking at this dial, my first glance is it appears to be over 70, between 70 and 80, so the first digit is 7. That's going to be a measured digit. And as I look at the placement here, it looks to be, to me, between 76 and 77, okay? So I will have measured 76 point something, okay? It's not quite the 77. This one right here is 77. And this one right here is 76. So it's between 77 and 76. So I've measured those 2 digits. Now, does it have a tenths graduation? It does not. So anything I report beyond where I'm at right now is an estimate or a guess based on the placement of the dial. Now, by my eyes, I mean, you may disagree with me. I'm just going to say that what I'm reading or estimating that last digit as is 0.8. So 76.8 would be my reading. It's almost 77, greater than 76 clearly, but this 0.8, I just estimated that. I don't know that that's true, okay? I just estimated it. So that's my estimate. I'm allowed to estimate 1 digit and only 1 digit, and I'm done, and that will be what I would report in my data sheet, okay? If I didn't report the 0.8, I would be selling myself a little bit short because clearly it's not all the way over here at 76. It's between the two, and I can tell the difference. Alternatively, if I was to report 76.85792481, that would be incorrect and almost kind of dishonest because I don't have that kind of precision to report my data. All right, so that should be my data that I report. Let's try one more of these. This is a frequent one that I see in the lab. In fact, when students sort of misread data and misreport data, I see this one come up a lot just because in the lab we do a lot of titrations. How in the world should we read this burette? Okay, and of course the burette's the long glass tube. You use it for titrations. You use it a lot in analytical chemistry lab. Remember, you always read that burette from the bottom of the meniscus, and well, on your video I'll say that that's right at this line right here, okay? It's a little bit hard to see because there's shadows involved in this picture. That line right there is where I'll say the meniscus is. You always read from the bottom for aqueous titrations. So, what should be the reading? Well, as I look at that, it appears to me that this is the line for 40. And I believe that the line for 41 is down here. This is 40.5. Okay. So here's 40. Now I look at that the bottom of the meniscus. It appears to me to be a little bit below 40. Okay. So I'm going to say 40 point something. Now the question is point what, right? Well, if we look closer, this is 40.5, so it looks like these tiny little graduations are 0.1 increments. So 40.1, 40.2, 40.3, 40.4, 40.5, and so on, all the way down to 41, which is down here in the shadow, okay? So then where are we at? Are we quite to 40.1? Well, that's right here. I don't think we are. Okay, so we're somewhere between 40.0 and 40.1. Now, have we read that digit? That first decimal digit. We in fact have. We know it's not 0.1, so it must be 40.0 something. Okay. I can in fact on a burette, because it's got 0.1 milliliter increments, read to 2 decimal places because I have not estimated yet. In this particular case, maybe I would estimate it as 40.03. Just kind of based on eyeballing where it's at. Maybe it's not quite to 0.5. I think it's 40.03 milliliters. Well, again, that last digit, that 3, is my estimate. All of the other numbers have been read. So these are readings. This last one is my estimate. Okay, so consequently, when you're in lab making measurements with burettes, you should always report your readings to 2 decimal digits of precision, because you can always estimate to that hundredths place. Okay, so let's see you do that when you're working in lab. Alright, that's all I've got for this video. Thanks.